Hello and welcome back. Today we are looking at sustainable businesses and how industry is addressing the climate crisis. I'm Tabitha Goldstall, co-founder of CogX, and it's a thrill to welcome you wherever you are today. Don't forget, you can send your questions into our speakers on the CogX platform and check out the expo and drop a line to some of the brilliant organizations we have showcasing. This next session is called Building a New Economic Future. With pioneering lab-to-market innovation, we have a chance to rapidly reform and build alternative industrial models that no longer rely on the fossil-based resources. Your chair today will guide us through this conversation. He's called James Talentier, the Communications Manager of the University of Manchester. James' connection isn't so great, so if we lose James, Adrian Nixon, the editor of Nixene, journal specializing in graphene and 2D modeling, might step in. But let's start with James. Are you there, James?
I'm still here, and while I'm here, everyone, hello to everybody. Hi. If you lose me, I do apologise now. So, yes, hi. Welcome, everyone, to our session, Building a New Economic Future. I guess part of the title reflects the phrase, build back better, which I think many of us heard recently. And this idea that we're in this pandemic, COVID-19 pandemic, this global crisis, but from which maybe we can look forward to build a new economic future and then seriously tackle the big challenge of climate change itself. Today, we'd like to look at two themes really within that proposition. One is about reforming, rebooting existing sectors, manufacturing, aerospace industries, the auto industry and their supply chains. How do we make them better? And also about revolution, doing something very different, building and making things in a different way, or at least to a scale that's never been done before. And to help me with that conversation, I have a panel of some excellent experts, journalists, academic leaders, innovation leaders and entrepreneurs. I have James Baker, Chief Executive of the Graphene at Manchester, Adrian Nixon, Editor of the Nixene Journal, Professor Rob Field, Director of the Manchester Institute of Biotechnology, and two entrepreneurs, Dr. Vivek Concheri, Chief Executive of Space Blue, and Dr. Bini Sadik, Chief Executive of AEH Innovate Hydrogel. Hi, colleagues. I'll just let you do some quick introductions. You can do it a lot better than me, and then I will come back and ask a few questions of each of you, if I may. James.
Hello. So, good afternoon, everybody. I'm James Baker, CEO of Graphene at Manchester. So graphene, the wonder material, first isolated in Manchester 2004, sticky tape and some graphite. You can all do this at home to create graphene. Nobel Prize for 2010, but I'm going to talk today about is how we take that great science from UK universities to create new products and applications in a way that were never achieved in the past. Look forward to speaking.
Adrian, please.
Hello, everybody. I'm Adrian Nixon, the editor of the Nixene Journal. We're a relatively new journal. We set up in 2017, and we create a monthly issue looking at the technical and commercial developments every month in the world of graphene and 2D materials. This whole field is moving really fast, and we're creating a 50-page issue to brief decision makers in industry and also academia, just to keep up with the pace of change. We're now in volume 4 of our monthly issues. We have a subscriber-based model, so we don't take advertising, so we like to think we're completely independent. And if you look at our YouTube channel, Nixene Publishing, you'll find lots of free source material out there as well.
Brilliant, thank you, Adrian. Rob.
Hello, Rob Field, Director of Manchester Institute of Biotechnology. So we are a university-based discovery innovation institute, which is very much industry-facing. So we're really looking to see how we can take the academic ideas of today and turn them into the commercial realities of tomorrow. How can we build those pipelines, setting up companies to de-risk activities, and then on to the bigger companies that would allow us to roll out at scale. So exciting and interesting times, but also challenging just at the moment, but that presents some new opportunities.
Absolutely, thank you, Rob. And then Vivek.
Hi, I'm the CEO of Space Blue Limited, a startup based in Manchester. I invented and developed a graphene-enhanced recycled rubber floor mat. This mat is actually made with waste car tire and graphene. One of the biggest challenges when you recycle any material is performance drop. Thanks to Graphene and working in collaboration with Graphene and Manchester, we solved this problem. We are starting the commercial sale of this mat next week on Tuesday through our website, www.spaceblue.co.uk. And we need your support, and together we can make a sustainable world.
Thank you, Vivek. Brilliant. And then Binish.
Hi, I'm Dr. Bini Sadik, CEO and founder of AEH Innovative Hydrogel Limited. Our company mission is to help indoor growers and farmers to grow crops in cost-efficient and sustainable way. Just recently, we have secured 1 million Innovate UK grant, and now we are working in Geek to develop this product and bring that product into market.
Fantastic. Well, thank you, colleagues. And if I may begin with some questions, and I will start with James. James, I mentioned we may face these existential challenges, COVID, and of course the big topic of today, climate change. Now, Manchester's famous as the home of graphene. Big expectations on this so-called wonder material. But really, how can this nanomaterial help existing sectors go green at a global scale?
So just building on the great introductions from the panel, 2004 sticky tape and pencil to create graphene, Nobel Prize in 2010. But one of the challenges we have is it can take many years, if not tens of years, to take a new material from the lab into products and applications in the marketplace. So whilst I talk a lot about graphene today, graphene is just one of over 100 two-dimensional materials. If you like, it's part of a broader advanced materials agenda. And I'm a strong believer that advanced materials will play a key role in terms of meeting some of the key challenges we have around sustainability. In the UK, carbon neutral by 2050. In Manchester, carbon neutral by 2038. But interestingly, just been on a webinar this morning. To achieve 2038, we actually need to be building green construction by 2028. Otherwise, there's huge retrofit that we needed in the future. So what's the role of advanced materials? Graphene as an example, and the literature, from the science, it has properties like 200 times stronger than steel. It's more conductive than copper. It can act as a perfect membrane. It's flexible. It's transparent. But the challenge is, how do you get some of those real properties into actual products and applications? And in Manchester, we have our National Graphene Institute that's focusing around the acceleration of the science, bringing the physicists with the material scientists, with the engineers. And we have the Graphene Engineering Innovation Centre, a catapult-like building, part of the University of Manchester, that can really accelerate, if you like, make or break, take these new ideas, these new concepts. And we can make everything from graphene into rubber, through to graphene into carbon fibre, for example, into lightweighting. To achieve some of our sustainability targets, we need lighter, greener aircraft that can fly across the Atlantic without emissions, without fuel. To do that, they need to have batteries, they need to have hydrogen fuel cells, they need to have lighter structures. Through to our cars of the future, our buses, maybe it's a combination of a battery with a supercapacitor. So all these areas of challenge around sustainability, of carbon neutral, graphene, advanced materials can play a key role in that. But the business model we need is very much one around collaboration, working with large corporations like Airbus or Rolls-Royce, through to working with government and agencies like Highways England. We're looking about putting graphene into roads so that we can have a road that is both more durable and tougher, but it also doesn't create cracks that turn into potholes in the winter or in summer. Again, one of those challenges that will be key if we're going to get our infrastructure and productivity, more sustainable in the future. So a key to that is very much around collaboration. Adding a small amount of graphene into a product can make a big difference, and you'll hear some examples later, from batteries, energy storage, through to lightweighting, through to water filtration. In the future, we could potentially have a graphene membrane where you could take dirty, salty, contaminated water through a graphene membrane into drinking water. So the Geek is very much around that collaboration. We're working with over 70 companies in Greater Manchester, small and medium enterprises, from startups to small existing businesses, and you'll hear from a couple of those later today. So for me, the answer to your question, James, is very much that graphene advanced materials has a key role, but we can't work the way we have traditionally and take 10, 20 years for new materials to come to the market. We're going to look at new business models, new collaboration models, but also how we really accelerate these new ideas and concepts into products and applications. And that's the opportunity I believe we have through graphene and advanced materials and this broader agenda of materials and manufacturing in the UK.
Thanks, James. That's quite a vision, and thanks for outlining that so well. Adrian, may I come to you now? Now, James there has that big vision, and he mentioned some things like infrastructure, etc. If I may, and can I just say I am a bit of a reader, a bit of a fan of your journal, and full of fantastic information. There's one article, actually, one study I think you led on, which really struck me. Picking up the points of James there and application, it's around adding graphene to concrete. And if I understood this, you're suggesting through the supply chain, you could end up with a reduction of about 2% of global CO2 emissions through that. Could you explain more? That does sound extraordinary.
It is, and I think that's an underestimate.
Right.
Just before we start, when Nobel Prize was awarded for graphene, people thought it's going to change the world, and then all of a sudden they realised they're just getting, this is graphene, they're getting black liquids and powders with a powder, and people thought, oh my gosh, this is really underwhelming. It's not really going to do anything, and graphene started to sort of get labelled with hype. And since probably over the last sort of 3 or 4 years, we've started to see graphene definitely coming out of the hype, and we've been monitoring different applications. One of which was graphene powders and liquids put into concrete. And when we started to look at the results, we just went, wow, people really need to know about this. So we took apart a lot of the literature that was being published, and we looked at what people were actually doing with graphene in concrete. And graphene, by the way, graphene is applied in all sorts of different areas. This is just one niche of something that graphene can do. So we took apart all the different studies and we put them together in a summary, because we try and create a summary on 1 page per topic for the journal. And the way we summarized it was looking across a range of peer-reviewed tests. And we found that on average, about 0.03% of graphene powder increases the compressive strength of concrete by over 25%. Let me say that again. 0.03% graphene increases the compressive strength by 25%. That's a quarter increase. Things like this are unheard of, and that's a vanishingly small amount of graphene. So what that actually means is, if you work backwards, then you need to use 25% less concrete for the same amount of strength. And then when you start to unpack that and dig in a little bit, we looked at how much global cement production accounts for global CO2 emissions. And Chatham House, which is a fairly reputable source, they reckon that cement production accounts for around about 8% of global CO2. Take a quarter off that, that's 2% of global CO2 emissions. Almost, you wouldn't really notice. I just happen to think that is absolutely staggering. That was a year ago. Since then, only last month, because again, this whole field of graphene and advanced materials is moving so fast to keep up. Last month, there's some work done by a GEEK Tier 1 partner, First Graphene and the Australian Research Council at the University of Adelaide in Australia. They've done some more work showing that the compressive strength is actually increased by 34.3%. The tensile strength is increased by 26.9% just by adding 0.01% weight for weight graphene on concrete. And that is some peer-reviewed test results already. So this stuff, we thought this needs to be got out into the outside world. People need to start really paying attention to this, because there are challenges. Maybe some of the Q&A might pick up on some of this, but boy, the benefits of trying this are going to be absolutely irresistible. That's just the tip of the iceberg, James.
Yeah, Adrian, that is an amazing case study, I have to say. I think the point there is what a tiny amount of this advanced material can do to make such a transformational change. So, you think, why is this not done sooner? But I guess this is where we come into it now. The COVID catalyst, we can do things different now. Seize the day, I guess. Is there enough graphene, by the way, Adrian? Would there ever be enough graphene for the kind of scale you're talking about?
Is there enough graphene? Oh, blimey, that's a very good question, actually. Andre Gein, the Nobel Prize winner, asked the same question a little while back. You'll probably remember. So you're in good company asking a question like that. As a result of him asking that question, I've sort of gone into the numbers because it's actually quite a valid question because we're talking about billions of tons of cement production. So even 0.01% graphene is going to be quite an amount. So when working through the numbers and looking at the first graphene data, we reckon that we run a few calculations and say there's around about 2.8 million tons of graphene powder required each year. Now, graphene is made from graphite primarily at the moment. So we looked into what the global graphite reserves are, and there are around about 800 million tons of graphite reserves in the world that we know about already. So if the economics go up a little bit as well, we'll probably find that's an underestimate. So just in terms of graphite itself, then there's going to be plenty of supply out there. And maybe something else we could possibly pick up on later is making graphene powders and liquids from graphite is just one way. There are actually some other ways of making graphene where we could liberate even more graphene. So I'll park that one for the minute because I'll open up a Pandora's box of information that we'd all dig into.
As ever, Adrian, yeah, there's always a Pandora. Yeah, you open those floodgates of questions, but fantastic. So basically, what I'm taking from James Baker, what I'm taking from you, Adrian, is advanced material, in this case, graphene, can absolutely transform what we've got already. Existing sectors, existing ways of doing things could be completely changed and meet the climate change challenge head on. Yeah. If I may, I'd like to bring in Rob Field now, because Rob, his field is biotechnology. And it seems to me, Rob, and you can correct me, but it seems to me your field could actually be the revolution as well. It could bring something that we've never quite had before, the biomanufacture, actually moving away from these fossil-based resources and do something quite different. Could you expand on that?
Yeah, sure. I mean, I think we're at an interesting time at the moment. I think a lot of the industry, a lot of the products we rely on in society are heavily dependent on the oil-based feedstocks, something we're going to have to move away from. But it's not just about feedstocks as such. There's so much more when it comes to manufacturing. There are all the waste streams to be considered. There's also the question of where do we get the energy from? And increasingly, where do we get the water from as well? So there are a lot of factors there to come to play. Biotechnology has opportunity to impact across quite a wide swathe of different activities, whether we're talking about production of food and biofuels, bioremediation. How are we going to generate the next generations of advanced pharmaceutical intermediates, vaccines, diagnostics? And then there's the fine chemicals, the biodegradable plastics, and sustainable materials in a broader sense. So biotechnology is a very broad church, and it could have an impact on all of our lives in very different ways. How are we actually going to realize that impact? So if you look back actually over a century now, where has biotechnology really transformed healthcare, for one example? So if you go back to the 1920s, you'll come across an academic lab that uncovered the production of penicillin, a nice academic curiosity that sat on the shelf for 20 years before anything really happened with that. And it wasn't until the 1940s that biotechnology processes really drove the industrialization of penicillin production, making it readily available. Now, of course, the 1940s was World War II, and it was in fact that global strife that drove the necessity to do things differently and not just do more of the same. So that was the coming together of academic curiosity and creativity with the pragmatism that comes from industrialization, commercialization, to take things through from that minuscule scale that you would get in an academic lab to what is necessary for rollout for societal impact and benefit. So one of the lessons that's been learned over the years, and certainly something that the Manchester Institute of Biotechnology is focused on, is that co-creation of research and development activity involving the academics and the industrialists at an early stage. Within the Institute of Biotechnology, we have the Future Biomanufacturing Research Hub, which is populated with the academics bringing their bright ideas to the fore. But we're working on real world problems brought to us by industry, the things they can't deal with at the moment, the things they know they're going to be under pressure from government about in terms of their waste streams, for instance, and their environmental sustainability. So that co-creation, echoing what James was saying, is absolutely key. You need to work closely between the academic creativity and the industrial pragmatism and realism if you really want to take something from idea to scaled impact. So trying to find new ways of working there within the MIB. We have our academic labs. We have some labs which are co-funded by academic funding and by industry, but are still based on discovery. And then we have the more pragmatic rollout as well towards that early scale of what's referred to as the valley of death. The bit that's difficult for the big companies to buy into because it's still a little bit risky, they're a little bit unfamiliar. We're entering into that phase of starting to de-risk the processes of tomorrow so that they're less of a problem for the big established industries to take them up. So we need quite a portfolio here, and the challenge that's facing is not just around COVID, but it's not only the challenge, there's the opportunity too. Brexit coming up, we need to be conscious of our supply chains for pharmaceuticals. We need to be conscious of our food security. So creativity in these spaces is absolutely critical going forwards. Because of the timelines on Brexit, the pressure to do it now, to do it yesterday, and not in 20 years' time are paramount. So these are exciting times for biotechnology. There are huge opportunities here to move away from the oil-based feedstocks that we're used to, the industries as we know them, the large chemical plants, and to move into something that's more sustainable. So that's absolutely on the agenda and part of the Manchester ethos.
Well, that's fantastic. That's beautifully articulated there, and quite a vision again from yourself. Are you, just to pick up on a point there, this notion of valley of death, scale up, and translating knowledge, ironically, like graphene, penicillin, whatever, curiosity in a lab, and how do you get all that into the real world? Perhaps our next two speakers are part of that delivery. We have, well, first of all, there's Vivek Concheri. If I come to you, Vivek, so basically, I mean, you are very much part of that the supply chain there that Rob mentioned is important to you as well. But first of all, if I understand it, Vivek, your spark into entrepreneurship is partly due to this knowledge, this realization that tires, old car tires from UK were shipped off to India and then set fire to, talk about climate change challenges, only how to contribute to it. So you decided, I think, to do something about that. So as a business, what did you do, and how ultimately will your supply chain work, do you think, in your business?
I just want to highlight, waste tire problem is not just a UK problem, even though it's 100
yes.
a day in the UK. Just to give an example, in Kuwait, waste tire graveyard can be seen from space with 7 million tires. So it's a massive problem. So just to catch up on what I learned from the whole journey of in finding product in the lab all the way to market is global. I mean, with the current COVID, global economy is at a crossroads. And traditional model of growth, economic growth, without the concern for environment won't work anymore, as well as carbon inequality. So we need to retool our growth towards sustainable product. To solve, waste tire is a massive problem. To solve this problem, it's a collaborative effort. There are many parties. First is manufacturers, then there is consumers, then there is government and innovation centers. Just to bring as an example, as a manufacturer of a sustainable product, we are focusing on local manufacturing for the local market. This doesn't mean we have no global ambition. We do have global ambition. So for an example, for the US market, we will make in the US using US waste tire. So but to solve this problem, we need consumer support as well. Sustainable products is no more a luxury for the few. It's affordable to all. And it's the choices we make. And thanks to advanced materials such as graphene, you don't have to compromise for the performance as well. We can optimize the performance of the recycled products using graphene. Governments also have a part to play. Just to give an example, producer responsibility regulation, which means a manufacturer is responsible for end-of-life recycling. If you add tires and more product into this category, then manufacturers will choose the right material to start with rather than companies like us dealing with a big problem in the end. It's like 250,000 tons UK is shipping abroad. And most important part is innovation centers, such as an example is Geek. They need to lead the way. They need to show it to consumers that something is possible. Just to give an example, if Henry Ford asks their customers what do they want, all the customers will tell him, I want fastest horse. So till the centers like Geek show it to the people, something is possible, people won't come forward. I mean, thanks to Nixon publications and COGX, now we are spreading the news, what's happening in the wonderful innovation centers, and especially in graphene, how it can change the world and make a sustainable future. One more thing I would like to say, like James Baker said, is fail fast, learn fast innovation model. Because world is moving so fast, we need to do something now. The current problem is, it's not a problem, it's a crisis. So we need to act fast to solve such a big problem. So what I think is to solve, together we can make a sustainable world, and innovation centers such as Geek need to lead the way. Thank you.
Thank you, absolutely, and it's interesting that the one theme that is coming through is this acceleration. You know, innovation is great and great science is good, but unless that's fast-tracked into our world now, we're not going to meet the policy demands. We're not going to meet, you know, the challenges ahead. So that seems to be a critical point. And then Bini, again, another entrepreneur, another great vision. So your business is part of your business is associated with agriculture, a point that Rob picked up on earlier. Agriculture is obviously a very important sector. And this notion of vertical farming, which sounds very interesting, this kind of urban farming, which is in itself an exciting idea. Now, you have an innovation that's going to actually transform that. And also, I think part of that innovation and some of the funding you've had from government is all about supply chain and supply sovereignty. Again, a point made by Rob earlier. So please explain.
Yes. So basically, firstly, I will highlight a few issues with controlled environment agriculture and then just go with the solution. So by 2050, there will 80% of food consumptions will be in cities, but this controlled environment agriculture, in simple terms, I will use like growing crops or vegetables without using soil, will play a vital role. But there are certain issues associated with controlled environment agriculture. Number one is higher operational costs due to energy consumption demands, and then second one is higher water usage. So this is basically to tackle these issues. We need to develop some kind of system that will enable growers to grow crops in a cost-efficient way. So, for example, one of our customer, a potential customer we are closely working with, they produce baby spinach for 26 weeks for you to supply to UK retailers. But the UK demand for food supply or for baby spinach is for 52 weeks. With controlled environment agriculture, they managed to produce for 26 weeks, but not for 52 weeks. So what we are doing, our business is developing a solution that will enable indoor growers to grow crops for 52 weeks without basically without using higher energy or water usage. So overall, our aim is to enable indoor growers to reduce the food mileage from farms to the plate. So that's it.
Great. And as I understand it, part of this will help with supply chain sovereignty, that we could actually do more growing, more agriculture, or more productive agriculture, should I say, on our own shores. It's that point I think Rob was making about Brexit, COVID itself. It's shown us that we need to do something different with the supply chains. Is that part of your model as well? This idea that you can we could do more in our own, whether it's UK or wherever, you know, is that something that's very important to your proposition?
Yes, so our idea is basically to help indoor growers to grow like crops in cost-efficient way without so that they can supply the food to UK retailers for 52 weeks or for whole year, rather than just producing food for like 26 weeks. So this is the main idea.
Fantastic.
Yeah.
Thank you. So, okay, some things come from there, and if I may, I just may revisit some of the speakers again. So, I think I might go back to the start there with James. So, one thing is coming clear is that it's how do you accelerate this change? How do you make things faster? I mean, Bini has got quite a bit of funding from government, for example. What's the best way to do this? Is place important? Is it a grassroots thing, innovation, or should it come top down? Should government be pushing it? How do we work this? Do you think, Joe?
Gosh, it's a very broad question. I think Rob touched on it.
Sorry.
Traditionally, innovation, can take many tens of years for a new advanced material from the lab to the marketplace. But we've all come accustomed these days to some of the changes from software, through apps on your mobile phone, etc. That why does it have to take so long for a new innovation to come to the market? Now, advanced materials aren't as simple as software or an app. There's a lot more work to do, but to start to answer your question, I think we need a mixture of government policy. So if I look at graphene as an example, we've had government policy that's been supportive of building and the National Graphene Institute, 61 million facility in Manchester. Also, we had 30 million from UK government out of a 60 million graphene engineering innovation centre, and also investment into universities around Henry Royce and around fundamental research. So government support of research, again, just to remind the audience, graphene was first isolated based on curiosity. We actually allowed some of our academics some headroom to investigate unknown things. It wasn't driven by a commercial imperative. Interesting around the penicillin earlier. So not always driven by a commercial imperative. That fundamental science in the UK still has a leading position in that. But for me, as well as that government intervention in terms of facilities, infrastructure, research, we need a new business model of collaboration with industry. We can't afford to wait necessarily for tens of years for that innovation to come to market. We do need that intervention, that partnership, that collaboration with industry to create supply chain, to create graphene as an example, not just by the gram, but by the kilo, by the ton, to use Adrian's example. So the business model is key, and Manchester around graphene and around MIB, we're developing these new collaborative business models, academics with industry, to try and accelerate the innovation. I think the other thing, and the World War II example was great, but I think now environmental sustainability, with COVID, I thought innovation might slow down because of the global crisis, the inability to meet with people. But thanks to these great platforms like Zoom and Teams and initiatives like CogX, for me, it's actually accelerated bringing people together to talk about innovation, to talk about challenges. Providing we can keep our facilities open and we can start doing the experimentation, I'm actually seeing a big acceleration in innovation and ideas. We're talking to partners now who we started maybe a month ago. Through days and weeks, we've done a series of meetings, brainstorms through WebEx. And these aren't just in the UK, they're across the world with designers from America, China, different regions of the country. And we're now kicking off projects, and we hope to launch early products in early next year. I mean, Vivek hit the nail on the head. With sustainability, we can't afford to wait. I'm from an aerospace background, and aerospace are now talking about carbon neutral aircraft by 2035. Now, if they work conventionally, I would argue the aerospace sector should have started that program at least 10 years ago. So they have to start thinking differently. We have to come up with new business models. And I think actually COVID can be a catalyst, as you use the term, to really accelerate some of that innovation. And the sustainability, for me, makes that even more important. Taking Vivek, we can't afford to wait. We need to do this now, and we need to accelerate it. So a broad answer, but partnership, collaboration, initiatives from government, support in terms of core funding, but we also need to bring in that public sector, private sector funding to really leverage this to create commercial difference going forward.
Okay, thank you, James. That's a good point. Rob, I'm going to pick on you actually, because you are the most senior scientist amongst us. So James, it's this push and pull, and it's the context. So now you mentioned a couple of contexts we just picked. You mentioned COVID, we mentioned Brexit. It takes something to accelerate what we do, how we respond to things. Graphene was curiosity, penicillin was curiosity, the example you made, and scientists just thinking about it in labs and come up with something really exciting. Then I think you said 15, 20 years was the lag between it actually being put into market because of the Second World War. Is there something here about scientists? Do they need to be thinking a little bit more ahead? Do they need to be thinking, actually, when I experiment, this actually could be applied? What's your views on that? Or is that unfair to scientists?
It's an interesting question. I mean, I think when times are tight and funding is limited, there is an innate Britishness that forces everything to become more and more conservative. It's actually the antithesis of what we need. Now is the time when we need bold thinking. Now is the time we need creativity. Don't forget, we only put a man on the moon because the US president said we're going to put a man on the moon. He didn't know how we were going to do it at the time, but we need bold leadership and big ideas coupled with the more pragmatic incremental things to take the steps that companies are comfortable with, that they can see a return quickly. There's financial stress right across the SME sector, right through into the big companies as well. So we need a portfolio of activities here, from the horizon scanning discovery of the academics, which may be longer term, but we also need those people who sit in that middle ground between hardcore commerce and academia, who can spot the ideas and spot the opportunities and build the bridges between the two. And I think this is the kind of opportunity that perhaps we can foresee with the Innovation District Manchester coming forward over the next 10, 20, 30 years, where we will have the academic and the innovation centres right alongside some of those next stage commercial developments. So I think we're in interesting times. Everybody has a part to play, including government, with brakes on taxation in some quarters for sure, but also incentivization by targeting funding to particular global needs. I think it's not a UK specific scenario. We're not going to solve the global warming situation simply by focusing on the UK. So we do need to think about that international context as well.
Thank you, Rob. Actually, if I may go back to Adrian. Adrian, you take a global view with the Nixon Journal, and just that last point that Rob's picking up there, we perhaps over focus a little bit on the UK here, maybe for good reason, and place is important, of course, but how do we compare in the UK perhaps elsewhere? Have we got a chance here, like in Rob's field in biotech and graphene at Manchester? Have we got an opportunity here to take some leadership here globally? What's your view? What would you say on that?
Yeah, it's tempting to run the UK down when you look at what's going on in places like, particularly China, funnily enough. We're seeing a tremendous amount of work, particularly around the concrete stuff. We're picking up now, the Chinese government is sort of pushing people towards experimenting with 3D printing concrete, and we're picking up that graphene is going into that. And it's tempting to say, oh yeah, the UK and the US actually are way behind. However, the stuff that's going on at the moment, I know James Baker at The Geek is lobbying hard to raise awareness of this in the UK amongst the key decision makers that matter, and you may want to talk a little bit about some initiatives that are going on there. There is a huge amount of work taking place at the minute, sort of socializing these ideas, getting acceptance, and getting groups of people together to say, yes, let's get ahead and do this. So there's a huge amount of stuff happening, I see, in the UK under the radar. I think when this stuff really starts to hit and take off, the groups come together, we'll start to see very, very visible signs of activity taking place. And it's due to, in large part, the graphene community, particularly a lot of the work that James does and the team around him about bridging between government, academia and industry. And bear in mind, this material has only been out for since 2004. It's still a teenager, as James says. So we're seeing lots of activity. General public at the minute will probably in about 2 to 3, 4 years suddenly go, blimey, graphene, it's everywhere. Where did that come from? So there are plenty of green shoots there and lots of activity taking place.
Right. Well, that's a very positive outlook. Thanks, Adrian. And now you look at Rob. He's a lovely man. He's a scientist. So, is there an issue, do you think, between you sit outside academia in a way, although you're very much part of our community in some senses, but is there still a view between industry that this is hard? Universities are hard to work with. Scientists are a bit distant. I mean, is that, you talk about this Venn diagram of the mix is that changing fast? Is it something that, or could that be accelerated as well? That perception.
Yeah, I mean, give you one example, just because we're just focusing on concrete at the minute. This is just one small part of the puzzle.
Okay.
You could argue that academics come along and say, okay, graphene makes concrete 25% stronger, therefore you need to use 25% less. So if I was being a bit cynical, I might say, okay, I'm a naive academic going to industry saying, got this great idea, you can use a quarter less or sell a quarter less of your product a year. And that would probably fall on deaf ears. However, listen to what the conversation has been doing actually here so far. Yes, at one level, you might say if you're trying to get, let's say, graphene into concrete, that might be a tough ask. But there's an awareness already in what the speakers have been saying that this is a sort of a little bit of a wicked problem. You need to approach it from different angles. So get the incentives right. Rob talked about this. James talked about government policy coming in. You get the behavior you reward. So if you want to start to get people using concrete and get the impact on climate change through global CO2 emissions, then government needs to play its part and make sure that people are rewarded for doing the right things in the right way and implementing these things, helping with regulations, all that type of good stuff. So it's on one level, you might think that academia is quite separate, but the graphene and 2D materials, this stuff is advancing so fast and involving so many people. I think actually it's beginning to sort of steamroller over these traditional boundaries. And generally, I am very optimistic about where all this is going. We just keep on getting the message out, keep on getting the awareness out, and you watch what happens.
Thank you, Adrian. That's brilliant. I might actually start looking at some questions are now coming in, and I might throw those to the panel now. From Peter. How does graphene fit into the circular economy, and can it be recycled itself? I mean, maybe James wants to answer that one first. Yes, can graphene be recycled? I mean, what's your view on that?
So I think Adrian touched on earlier. So graphene, is carbon. It's a form of carbon. So generally we make graphene from several sources, from graphite, as Adrian described earlier. So we take graphite and we break it down into sheets or a few sheets of carbon. And we also take it from a gas, for example, methane or potential carbon dioxide in the future. So Adrian touched on, maybe comment, there's still some processes need to be developed, but ultimately carbon is in the ground, it's in your body, it's in the air. So, taking something like carbon from graphite or from methane, so some producers take food waste to create methane, which you can then take the C out of methane, if you like, the carbon out to create this graphene. So potentially it is ultimately in the circular economy. But then I also look at Vivek's product. He's taking an old tire, chopping up, adding graphene to create a mat. When that mat is worn out or is old, or you want to recycle it, you can just repeat that, cycle that product, add a bit more graphene to go back to its original properties. So as well as the graphene itself being circular, potentially we can get these circular, it can enable circular recycling. Vivek mentioned it. Traditionally, when you recycle a product, you lose a lot of the mechanical or the performance of that product. But by adding advanced materials, if you can go back towards the original performance, it makes the recycled product an attractive alternative. So yeah, I think it plays a big part in this whole recycling and circular economy going forward.
Thank you, James. A question from Jen here. I might have to keep you on here. Sorry. So it's are you hoping? No, sorry. Oh no, actually, Tom. Actually, I've got to do Tom's question next. What are the essential components of regional innovation hubs like Manchester? Actually, that might link into both Rob and James here. Now, Rob, you have a manufacturing hub in biotech, don't you? At MIB. So that sounds exciting. That's a hub and spoke model. How do you feel about this place and this regional innovation? Are you confident in that?
Yeah, I mean, I think this is absolutely the way to go. I think looking at somewhere the size of the UK, we can't have everything everywhere. We need exemplars. We need examples of where we've built it, and they will come, I suppose, is the way to look at it. And whether that's on the graphene side or on the biotechnology side, I think Manchester is very well placed in this regard. I think the hub and spoke model is attractive to government because it's demonstrating that we're not an ivory tower sitting in the middle of a city and paying no attention to what goes on elsewhere. The Northwest and the Northeast have a very substantial agricultural economy. one that is indeed complementary to the activities that we've heard about today. And I think they both have an incredibly important role to play as we go forward. So I think it's important that we join up what is traditional farming activity, if you will, and industrial activity on the other side. So a melding of the dark satanic mills and green and pleasant land, I suppose, if you will, to see where we go going forward. And it's greener and more pleasant for all concerned.
Fantastic. Yes. So the North reinvents itself. And James, I've often heard you talk about a Manchester model. So I know and you talk about Manchester as the home of graphene, etc. Place is very important in that narrative. That must be a good thing, I guess, and especially for regional innovation.
Yeah, I mean, for me, place is very important. But when we talk about place, building what Rob said, it's about distinctiveness. Yeah, we're not trying to create Manchester as an example the same as Oxford or Cambridge. Oxford and Cambridge, as an example, have their strengths. The University of Manchester has its strengths. It has 5 what it calls beacon areas. One of those is around advanced materials, and it's been recognised through the creation of the Royce Advanced Materials Institute that's centred in Manchester, but involves 8 other universities across the UK. So it's not about repeating, it's about leveraging the strengths. We work closely with the Catapult organisation, so things like the Advanced Manufacturing Research Centre in Sheffield, National Composite Centre in Bristol, the Centre for Process Innovation in Durham, just to give you a few examples. So for me, it's about leveraging that capability across the UK, which probably comes back to government intervention, the role of companies like Innovate. Bini has been very successful in winning a significant grant from Innovate UK, which enabled her to bring a focus in Manchester, but she's also working with partners across the Northwest, across the Midlands. So for me, the place is important, but it's about how we establish the links. I mean, there's another question about talent from London. I think
yes, exactly.
Place is important, but we need to bring physical things together at times. But actually through Zoom and through Teams, we've almost neutralised the fact that traditionally, Manchester is only 2.5 hours. I think we were on the news about 3 years ago. A minister at the time, I won't name him, sort of said he had to take a helicopter from London to Manchester because it was a bit too inconvenient to go on the train for 2.5 hours. I think now in this new COVID world, through Zoom and through WebEx, we can be in the UK in the morning, we can be in America in the afternoon, we can be in Asia the following day, virtually, of course. So I think place is important, but it's about leveraging capabilities and more important.
Very good. Yeah, I agree with that. Okay, that's a good point. Okay, a technical question here, and I don't know who's best placed to answer this at all, really. Is there any other technology being applied in construction materials, I suppose, other than graphene? I don't know if there's a biotech answer to that, Rob, but it's an interesting question. I suppose the answer is yes. What that would be? Anybody can throw in on that one at all? Adrian, maybe you might. You're quite. You're
I have heard, well, it's not graphene, but I have heard, and Rob will know probably more about this than I will. Cracking in concrete is a big problem. So by adding bacteria that create like a calcium carbonate shell around them, where you put them into the dry concrete, and when they get wet, they activate and start producing the calcium carbonate again. So effectively, you have a self-healing concrete, because when the cracks occur, lets the water in, the bugs get going. I don't know if you know any more about that than me, Rob.
And not that one specifically. I think there are a lot of activities in that general space as to how we can harness organisms that are already out in the environment. So there's no GM angle on sort of this, to produce materials that complement some of the harder materials we might use. Another example, certainly one from Manchester, is current work looking at spider silks and how we can produce them at scale without using spiders. And also with that, to look at the structure and property relationships of some of those materials by looking at a much wider range of species of spiders without ever going near a spider. So it's providing different ways to access tunable properties in materials, I think, from the biological side, whether that's coming from crop plants or whether it's coming from bacteria or fungi, or indeed from seaweeds. So there's a lot of opportunities to complement those renewable feedstocks with the concretes and so on of this world, for sure.
Wow, that's an amazing, interesting collection of feedstocks there from all sorts of materials. That's quite interesting. And then there's an interesting question here, actually, and I think this is the panel actually as a whole. So as a consumer, says Giganta, will I see industry-wide adoption of durable graphene in footwear from major sporting brands to luxury goods? And then interesting, the point being made here, will that mitigate fast fashion? The durability of the product, will that mean we have less landfill? I mean, that's something I think Vivek's been involved in a lot, and that avoidance of landfill and recycling, etc. But any response to that, Sir Vivek?
I mean, the current question is regarding the shoes. Shoes is also a footwear, especially graphene, long-lasting one. The question. I mean, we don't want anything to go to landfill. So even in the case of shoes, we need to start recycling it. And if you think about UK, more than 70 million people, and it will be a very large number of shoes, and it will end up in landfill. So we need to reduce that by recycling it, and graphene does help in that, because if you take the old shoes and make it a new, use the sole and make a new shoes with that, you can use graphene to enhance the performance. So graphene does help going forward to make high quality products.
Fantastic, James. I mean, one example, James Baker. One example that just springs to mind. I don't know if the person there's knowledgeable. There is a graphene shoe, isn't there? There's one. I don't know if you've got one handy to show the crowd here. You
so happens.
it never fails.
So for me, it really answers the question. One of our partners has looked to put graphene into the rubber on the sole of the shoe. So traditionally, you have a trade with rubber. You can have a very soft and grippy rubber, but the consequence, it tends to be not very durable. So this is an off-road shoe for fell runners, and it gives you great grip. But some of the runners, professional runners, semi-professional, will wear the shoe out after 200 kilometers and end up that shoe being on landfill. By adding graphene, they've got a very soft, grippy rubber, but it's also more durable, 50% as a material. Well, that then translates into a shoe that typically can, instead of lasting 200 kilometers, lasts over 1,000 kilometers. So again, just one case study where by adding graphene into a material, we can do that trade. We can get something that's grippy and soft. So if you Google the runners, you're finding they're breaking the records now because they're running up the hills faster. They've got more confidence because of the grip on slippy, wet rocks, but they're now having to buy less shoes and throw them away because they're lasting that much longer. So again, I think it's just a very quick case study there of advanced materials can start to play with the trade. It's a bit like the concrete and the construction example. Carbon fiber, a lot of talk about using carbon fiber, but by adding graphene into glass fiber, you can actually improve the properties of the glass fiber. Again, one of our partners is putting that into swimming pools as an example in Australia, where traditionally you might need a carbon fiber, very expensive, very tough, but by adding graphene into glass fiber, you can actually make a glass fiber structure that's both strong, but it also stops the water from leaching through. So again, advanced materials have this multifunctional property, and where graphene starts to make a real difference, if you can have something that's got both performance properties and durability and life, as well as recycling, you start to really create competitive advantage for your consumer or for your industry.
Thank you. Coming to the last of the questions now. That's so, and here's one actually that kind of reflects what we talked about earlier in this idea from it's anonymous. But do you think we support our universities in the UK enough to let them do the research might eventually lead to the innovation of products? I mean, maybe, I don't know, Rob wants to answer that one, but are we getting that support? We talked about this partnership, between government, local authorities, business, and universities. Is it enough? Or obviously, I suppose you'd like to see more, but how would that happen?
It depends where you want to focus in that question. If you want to focus on the innovative products at the end, there's a gap in the funding opportunity to take the innovative ideas from academia through to products. So there's certainly some shortcomings in that middle ground. Government is talking about a mission-orientating funding agency to emulate what they have in the US to bridge that valley of death. From the discovery side, there's always plenty more discovery one can do. I think what we've learned over the last century or so is that it's difficult to predict what you need to discover in order to translate down the line. So it's really important that we keep a robust and broad fundamental science base in this country. So more funding into basic science will sooner or later to lead to those products, but it's very difficult to judge which basic science will lead to which kinds of products.
That curiosity issue you mentioned earlier. I might actually, can I go back to Bini? Now you obviously you had a PhD just a few years ago. You're an early career academic, or you would be an early career academic if you pursue that line. You won an award, so you did get that push. You've had that support as an innovator. The El Harari Award. How did that transform your business opportunity, Bini?
Yes. So firstly, I graduated from University of Manchester in 2019, and after that, basically, instead of following traditional route to academia, in my mind, I was like, I want to develop some innovative product, and for those things, we need some sort of initial seed funding. And I think El Harari Graphene Enterprise Award helps me a lot, because from that seed funding, I have developed some prototype, and we got some results, and that led to win 1.4 million Innovate UK grant. So yes, I'm saying it's quite helpful.
Brilliant, that's great. Well, it's great to hear that case study, and then look where it's led to. You know, within a few years, well, I don't know how long, 14 to 18 months of a business, you're landing, you know, quite considerable investment from government to push your idea forward. So I suppose you are that living case study of how we can support science and scientists to innovation. That's fantastic. Actually, I suppose we are thinking about coming to the end of the session, but what I would like to do is each of you just to give I mean, Adrian, I'm going to start with, I think, because you are the most optimistic person. Everyone's optimistic here. You are the most optimistic. You're man of the match when it comes to optimism, Adrian. So, future economic, building an economic future that's going to be green and fantastic. Are you optimistic, Adrian? What do you say? And are we going to do it in time? What's your view on that?
Yeah, incredibly. I mean, the reason I'm optimistic is I'm monitoring this whole world of graphene and advanced materials every single day to produce a journal every month. Every single month, I'm seeing something that makes me go, wow. And you'll start hearing about this stuff. I think basically, if you've heard graphene is all hype, think again. It will change our world. The pace of change is astonishing. Just to give you a minor example, Ford Motor Company, they've now put graphene in all their cars. It goes into the urethane foams, and these are recyclable. And there are well over 1 million Ford cars on the road today with graphene in them. So if you buy a Ford car tomorrow, it'll have graphene in it.
Wow. Okay. So that's reached that tipping point, I think you're saying there.
Yes, I think that's a very good point, James. Yeah.
Rob, what's your view? Are we going to meet these challenges in time? As a scientist, have we left it too late, or are you confident?
Never too late. Never too late.
Never too late.
There's always a need for more money. There's always a need for more infrastructure. But at the end of the day, it's all about people. And it's fantastic to be on a call with two of those innovative young people who will save us all with a bit of luck. So I look forward to seeing their developments. No pressure, of course.
Absolutely, yeah. That's you. That's Vivek and Bini. So Bini, any comments from you? I mean, obviously you got a green future ahead of you. You're very much in the industry there, but you're very confident about your business, I guess.
Yes, so I can see, like as he said, it's not too late. Because there are lots of things I cannot discuss due to IP issues, but I can see like graphene. I mean, within 2 to 3 years, graphene will revolutionize agriculture and indoor vertical farming system, and I'm mega optimistic about this. Yeah.
Fantastic! It's amazing. Well, I'm just gonna. We're reaching the top of the hour, really, and I think it's been a fascinating session. I mean, the thanks everybody here for your contributions and your thought leadership. It's great to see. It is great to see such optimistic views, and it's great to see, like you say, Rob, to see the people like Vivek and Bini delivering, and the visions from yourself and James there, and Adrian. You got to keep telling those stories more. I mean, it's a fantastic journal, so we'll put that very positive message there. So basically, yeah, that's for me, it's been a really fascinating insight into how we can actually deliver a new economic future. So that's been very rewarding. So yes, just say thank you for me, and hopefully I'll hand over to Elena now.
Hi. Well, my God, that was so fascinating. Thank you so much. I feel slightly like my eyes have been opened to the promise and possibilities of graphene. I couldn't help at one point thinking about my big fat Greek wedding and the father's insistence that Windex would fix everything. I hope that graphene has much more potential and possibilities than that of Windex. But it's been such an amazing morning. What have we learned? There's been so many interesting conversations and insights and tidbits of knowledge. I've been kind of going, oh, wow, I never knew that many times. I think we've underlined every single session that we really need to be looking at collaboration and partnerships. And we need to be bringing together academia, policy, our amazing young entrepreneurs and innovators who are out there trying every day to put their products into market and to scale them and build them, and also with our funders and government. There's a lot of work to be done. It is our pleasure, as always, to host these conversations with us here. You can, of course, catch up on any of the conversations that you might have missed looking on our site, cogex.co. Do sign up for membership. There's a gold membership that is currently being offered free with no further commitment. And if you do that, you can see everything that's gone in the past. And I hope also that you'll join us again next week, because next week we're looking at what's next for the NHS. It's going to be a fascinating discussion. We have some extraordinary people joining us, and do look out for that now. But it just remains for me to thank you all for tuning in, and I hope you come and join us again next week. Thank you so much.
Want access to more CogX videos? Subscribe now for free at cogex.co.